So, when you think about machine learning, what comes to mind? Probably a lot of code, maybe some complex algorithms, right? But what if that's kind of missing the point? What if we started thinking about AI systems less like code and more like towering skyscrapers? Because just like any skyscraper, you can't just start building. You need a plan. You need a blueprint.
I mean, really think about it. How would you build a skyscraper today? You wouldn't just grab a bunch of steel and start welding, would you? No way. You'd need blueprints, and not just one simple drawing, but a whole set of them, right? You'd have plans for the structure, for the electrical system, for the plumbing, each one giving you a specialized, crucial view of the exact same massive project.
And that's the thing. Building a useful AI system, it's exactly the same. It demands its own master set of blueprints, so you can see the project from every single critical angle. So, where do we get these blueprints?
Okay, so how do we actually do this? Well, thankfully, there's a formal framework for it, and it's called the 4+1 view model. You can think of this as our master set of blueprints, a system designed to help us understand the architecture of pretty much any machine learning system you can think of.
And here it is. This model, which was inspired by classic software architecture, splits any ML system into 5 interconnected views. You see those 4 boxes on the outside? Think of those as the cornerstones of our building. And that oval, right there in the middle, that's the special sauce, the crucial +1 that ties this whole thing together.
All right, let's start by digging into those 4 big cornerstones: accuracy, complexity, interpretation, and operations. And just like our skyscraper needs plans for the foundation, the wiring, and the plumbing, each one of these tackles a completely different but absolutely vital piece of the puzzle.
Okay, first up, accuracy. This is the one everybody thinks of, right? How good is the model? But here's the key insight, and it's a big one. A model's performance on the data it trained on is almost meaningless. No, the only thing that really truly matters is how well it generalizes, how well it makes correct predictions on brand new data it has never, ever seen before.
And you know, getting this right is this classic balancing act called the bias-variance trade-off. If you have high bias, you're underfitting. That's like the student who barely studied. Their ideas are way too simple. On the other hand, high variance means you're overfitting. That's a student who just memorized the textbook. They're perfect on the practice questions, but totally fall apart on a new problem. What we're always looking for is that sweet spot, that perfect fit right in the middle.
All right, on to our next blueprint, complexity. And this view is all about the nuts and bolts, the really practical stuff. It answers a simple but critical question: what's it going to cost to actually run this thing? Because you could have the most accurate model in the history of the world, but if it's too slow or costs a fortune to use, well, it's basically a very expensive paperweight. It's useless in the real world.
So how do we measure this complexity? Well, it usually comes down to 3 key resources. First, there's time. How long does it actually take to train this thing and then get a prediction out of it? Then there's space. How much memory and storage is it going to eat up? And finally, sample. How much data does it need just to learn in the first place? Every single project has to balance its hunger for accuracy against these hard, real-world limits.
Okay, blueprint number 3, interpretability. And listen, this one is becoming a huge deal. See, it's not enough anymore for an AI to just spit out an answer. We need to know why it gave that answer. This is all about cracking open that infamous black box to really understand a model's reasoning. Because without that, you can't have trust. It's that simple.
When you have a model that's easy to interpret, it lets you do something absolutely critical. You can figure out cause and effect. You can pinpoint exactly what piece of information led to a specific conclusion. And that allows you to justify the model's reasoning, which is non-negotiable in high-stakes areas, like when you're talking about a medical diagnosis, or whether or not you get approved for a loan.
And that brings us to our final cornerstone, the operations view. You'll hear people in the industry call this MLOps. And this is the blueprint not just for getting our AI skyscraper built, but just as importantly, for keeping that skyscraper standing tall and running smoothly, day in and day out, with total reliability.
So at the very heart of MLOps is this cool automated pipeline. It flows from continuous integration, where you're adding new code, to continuous delivery, where you're deploying the model, and then, and this next part is really the secret for AI, to continuous training on new data, all while it's under continuous monitoring. What this pipeline does is it transforms the model from this static thing you build once into a living, breathing system that can actually adapt as the world changes around it.
Okay, so we've walked through the 4 big cornerstones:
But what about that +1 that's been sitting right in the middle of our diagram this whole time? Well, it turns out this little piece is actually the most important part of the entire framework. Seriously, it's the foundation that everything else is built on.
So that piece in the middle, that's the scenarios view, and it's all about one word: why. It defines the actual real-world problem you're trying to solve. Who is this for? What do they actually need? And the answers you come up with here, they literally dictate every single decision you make in those other 4 blueprints.
And this is where it all clicks together. This is the magic of the model. See how everything starts from the scenario in the middle? That why defines what you need. Does your scenario demand crazy high accuracy? Well, then you better be ready to manage that bias-variance trade-off we talked about. But wait, that's going to be in tension with complexity, right? Do you actually have the time, space, and sample resources to pull that off? And what about interpretability? Do you need to explain cause and effect to your users? Because that choice is going to impact your operations pipeline. It's this beautiful web of trade-offs, and it's all driven by that one central problem you're trying to solve.
So all of this, it all leads to one really, really important takeaway. Next time you're looking at an AI system, whether it's one you're building or one you're just thinking about using, there's a very specific question you should be asking.
Now, the easy question, the one almost everyone asks, is just, is it accurate? But honestly, stopping there is a massive mistake. Because as we've just seen, an accurate model that's too slow, or that nobody trusts, or that's impossible to maintain, that is a project that is absolutely doomed to fail in the real world. So the real question, the much better question, is this: is it well architected?
Does it actually have a complete set of blueprints? Does it intelligently balance the trade-offs across all 5 of these views? Because at the end of the day, a well-architected AI isn't just a clever piece of code. It's a system designed to work and to last in the real world. So the only question left to ask is yours?